This video is going to show the solution for a cost of electricity problem. Suppose electricity costs 12 cents per kilowatt hour, a hairdryer is plugged into the wall, and the hairdryer uses 1875 watts on the high heat and high airflow setting. How long would it take to use up 5 cents worth of electricity? Start this problem just like all the other problems given, but I'm not using variables. Instead, I'm going to use dimensional analysis. And I'm going to use dimensional analysis not to convert numbers, but actually to eliminate numbers. So what I'm going to do is I'm going to start with the cost of electricity and eliminate the other variables from the problem. So if I look at this one, the first thing I got to do is I got to match up my units. Hours don't have anything else like it, but the kilowatts and the watts don't match. So I'm going to convert watts over to kilowatts using dimensional analysis. So I'll start with 1875 watts, and I'll use the equation of the relationship between kilowatts and watts. So I know that 1 kilowatt is equal to 1,000 watts. So I'll set up my fraction so the watts will divide out, do the math, and I get 1.875 kilowatts. So now instead of 1875 watts, I'll mark that through and write it as 1.875 kilowatts. So that becomes my new given. So I'm going to use that later on. Now, dimensional analysis. So I'm using dimensional analysis to eliminate variables. So I need to rewrite my fraction. I've got this cost of electricity. I can either write that the way it's given as 12 cents per kilowatt hour, or I can write it the inverse of it, at kilowatt hours over 12 cents. The method I'm going to choose is the one that has my unknown in the numerator. So the question is, how long would it take to use up 5 cents worth of electricity? How long? In other words, how much time would it take? So I need the variable of time in the numerator. In this case, it's going to be hours. So I'm not going to write it the way it's given. I'm going to write it upside down so that what I'm looking for is in the numerator. This is how you approach all these problems. Whatever you're looking for, you start with the cost of electricity and put it in the numerator. So I'll start by writing this upside down as kilowatt hours over 12 cents. Now I need another variable to eliminate the ones I don't want. So I don't want kilowatts and I don't want the dollar sign. In this case, on the left hand side where it says givens, what I'm going to do is I'm going to match it up. So kilowatts in the numerator. That means that when I rewrite it, I'm going to put kilowatts in the denominator. So kilowatts divide out. So now I've got 1 over 1.875 kilowatts in the denominator. Then I will get rid of the dollar sign by taking the 5 cents and putting that in the numerator of the next fraction. So now my dollar signs will divide out. This is how you always solve these problems, to eliminate variables. Or eliminate units, sorry. Now it leaves me with hours in my answer. On the calculator screen, what I'm going to do is I'm going to take everything in the numerator and divide it by everything in the denominator. And once I've done that, I'll get my final answer of 0.22 hours in order to use up 5 cents worth of electricity.